All right, welcome to The Explainer. Today, we're going to pull back the curtain on the invisible magic that lets your computer do, well, a million things at once. It's called CPU scheduling. And it all starts with a question you've probably never even thought to ask. I mean, seriously, think about what you're doing right now. You've probably got a browser with a dozen tabs open, maybe some music playing, a file downloading. How on earth does one single machine handle all of that without just collapsing? It really feels like it's doing everything at the same time. But is it really? Well, the secret, it all comes down to this one brilliant, high-speed brain inside your computer, the CPU, or the Central Processing Unit. This thing is the workhorse. It executes every single instruction. But here's the crazy part, the real catch. A single CPU core can fundamentally only do one thing at a time. So how does it pull off this incredible magic trick? This illusion of doing everything at once? Okay, to really wrap our heads around this, we're going to use an analogy. Let's imagine your computer isn't a computer at all. Instead, picture a super high-end, ridiculously busy restaurant kitchen. You know, the kind where everything is chaos, but beautiful chaos. This is where all the action happens. So, in our kitchen, the CPU, that's our star head chef. This chef is a genius, incredibly fast, unbelievably skilled, but they have one simple, unbendable rule. They can only cook one dish at a time. That's it. One thing at a time, and all your programs and tasks, well, those are the food orders flooding into the kitchen. Every single thing you do, from a simple mouse click to rendering a huge video file, is like a ticket printing out. And just like in a real kitchen, some orders are just quick appetizers that take a few seconds, while others are these complex 5-course meals. And this, right here, is the absolute heart of the matter. CPU scheduling is basically the kitchen system for deciding which order our chef should work on next. It's the brain of the operation, the thing that makes all the decisions to keep the whole kitchen from descending into chaos. Okay, but this is where it starts to get tricky. I mean, what makes a good system for deciding what to do next? Turns out our kitchen has some seriously conflicting goals. It's a classic dilemma. See, on one hand, the restaurant owner, they only care about one thing, throughput. How many meals can we get out of this kitchen per hour? More meals, more money. But you, the hungry customer, you couldn't care less about that. You care about response time. How fast do I get my appetizer? And here's the problem. If you try to maximize one, you almost always have to sacrifice the other. So to even begin to solve this puzzle, the kitchen manager has to lay down one fundamental rule. Let's say the chef is deep into making some complex 45-minute dish. Can they be interrupted? Can someone run in and say, hey, stop that, we need this 1-minute appetizer out right now? That question, right there, is the huge difference between what we call non-preemptive and preemptive scheduling. A non-preemptive kitchen, the chef starts a dish, they finish the dish, no interruptions, period. But a preemptive kitchen, the chef can be told to pause, put that big dish aside, whip out the urgent order, and then come back to the first one later. And believe me, this one choice, it changes absolutely everything. All right, let's put this into practice. Let's look at a specific recipe, or as it's really called, a scheduling algorithm, and see how it actually plays out in our kitchen. And we're going to start with the simplest one you can imagine. Okay, so here are today's orders. You'll see the term burst time on the slide. Don't let that throw you. In our kitchen, that's just the cook time. So we've got one big order, P1. It's a 24-minute job. And then we have two super quick ones, P2 and P3, and they each only take 3 minutes. Now, our kitchen is using the most basic strategy in the book. First come, first served. It's non-preemptive, so no interruptions. And I mean, it sounds perfectly fair, doesn't it? The first ticket that prints is the first one the chef works on. Simple. So let's run a scenario. Let's say that big 24-minute order, P1, comes in first. Then right after, the two little 3-minute orders come in. The chef grabs P1 and gets to work. P2 arrives, gotta wait. P3 arrives, it has to wait too. Everyone is waiting for that big order to finish. So what's the result of this fair system? An average waiting time of 17 minutes. Think about that. Those poor little 3-minute jobs had to sit there for what feels like an eternity, all because they got stuck behind the big one. Sure, it's fair in one sense, but it is terribly inefficient. Okay, but here's where it gets really interesting. What happens if we have the exact same orders, using the exact same strategy, but they just happen to show up in a different order? All right, scenario 2. This time, those two quick 3-minute orders, P2 and P3, they arrive first. The chef grabs them, knocks them out, boom, boom, back to back. Both are done in just 6 minutes. Only then does the chef even look at that massive 24-minute order. And get this, the new average waiting time, it drops all the way down to just 3 minutes. That's a huge improvement. And we didn't change the strategy at all, just the arrival order. This right here shows a massive, fundamental flaw in this simple approach. This problem actually has a name. It's called the convoy effect. And it's a perfect name, right? It's like being stuck behind a slow-moving truck on a single-lane highway. One slow process can create this massive backup for all the fast little processes behind it. And this exact problem is why computer scientists invented much smarter algorithms, like shortest job first, which, as you can guess, prioritizes the quick tasks. So, let's bring this back from the kitchen to your computer. How does this all apply in the real world? Well, our simple one-chef kitchen is just the beginning. A modern computer, it's more like a massive, globe-spanning culinary empire. Think about it. In today's digital kitchen, you don't just have one chef. You have multiple chefs working at once. That's your multi-core processor. You've also got VIP orders. That's called priority scheduling. And it's what makes sure that moving your mouse always feels responsive, because it's a higher priority than some background download. And you have special express lanes, or what we call multi-level queues, specifically to keep those quick interactive jobs from ever getting stuck behind the big, slow ones. The whole system is designed to balance both that speed and that fairness. And here's the mind-blowing part. This constant decision-making, this invisible juggling act, it's not happening every few minutes, like in our kitchen. The scheduler in your computer is making these choices millions, sometimes billions of times every single second. It is the unseen conductor orchestrating your entire digital life. So the next time your computer feels like it's just effortlessly handling a dozen things at once, take a second to remember that brilliant, frantic scheduler working tirelessly behind the scenes. And that leaves us with one final thought, right? As our digital lives get more and more complex, we're talking virtual reality, AI, you name it. What are the next great recipes for scheduling going to be? What's the next big idea that's going to keep all of this running smoothly?